Yes, recording. Okay. So number one, find the perimeter of the new trapezoid. If it's isosceles, that means that this side here is the same as this side there. So we can find the perimeter of the original by adding those up. 18, 12, 10, and 10 adds up to 50. Thank you. So the perimeter of the original is 50. We have a scale factor of what? If it's doubled, you have a scale factor of 2. So to find the new perimeter, since perimeter is in one dimension, we just take the original times scale factor just the way it is. So 50 times 2, 50 times 2, like Stephen is trying to tell us, is 100. Everybody should have got that right.
I get 80. I got that. Do I get some popcorn? I got it right.
No. Text her, I said hello.
Okay.
Alright, square has its dimensions changed proportionally by a scale factor 3. If the new perimeter is 132, what was the side of the original? Okay, so we're talking about perimeters, so we can use the same formula. We're talking about two squares, so we can draw two squares, one bigger than the other. And it tells us that the new square has a perimeter that's 132. So how would we get back to the original?
You would have to find the size of the first perimeter.
Well, we have to know the original. We don't know what the original is yet, do we?
No.
But we know the scale factor is 3. So like Leighton is telling us, we can divide 132 by 3.
Keyboard.
Original. OG.
Keyboard.
So that's 12. So we get a perimeter of what? 44. And since it wants the length of each side, we can find perimeter by dividing it by 4. We get 11. You can double check that because 11 added to itself 4 times is 44. All right, we're going to try to get through the front page as quick as we can because I know a lot of people got all that right. No. All right. Jimmy designing a logo for his business. He's needs to enlarge a rectangle. All right, so it was small. It needs to be 3.5 times bigger. Goodbye. So what is the perimeter of the new shape? So it was 1.5 by 2. Could we find the perimeter of that? What would it be? The original. It would be 7. Just add all those up. And then our scale factor is what? If it says it needs to be 3.5 times the original, that means our scale factor is 3.5. So we have the original, which is 7, times 3.15. That's just a math problem. What does that work out to? 24.5. You could have rounded this. You could have used a little bit of common sense. 7 times 4 is what? 28. And only one of those answers is anywhere close to that. 21. See, yeah. Say. All right, number 4. Triangle is dilated with a scale factor of 0.625. The original was 64 inches. What's the perimeter of the new shape? So again, we have an original of 64. We have a scale factor of 0.625. So what do you have to do with those two numbers? Just multiply them.
Yeah, boy.
So 5 times 4?
20.
4 times 2?
8.
Plus 2?
10.
6 times 4?
24. 25.
25. Before we go to the second number, we have to bring down a 0. 6 times 5?
30.
6 times 2?
12. 13, 14, 15. Wait, what grade are you in? 36. 37.
Yes, and they did better.
I'll teach you guys too, because you're in 8th grade. We're going to be on YouTube.
So this does add up to 40,000, but how many decimal places do we have?
3.
We have 1, 2, 3. So we have 1, 2, 3 in our answer. So it would have to look like 40. If you wanted to, you could fill in the zeros on the right side, but I wouldn't.
I was so close. I got 38.
Well. All right, number 5. Dimensions shown or changed by a scale factor 1.5. What's the perimeter of the new? Okay, so same thing as the rectangle. You just add up all the sides on the original. You get what? 56. Okay. And then we have a scale factor of 1.5. So we have 56 times 1.5. Okay, first of all, the answer can't be 56. The only thing you multiply 56 by to get 56 would be 1, which this is not. Yeah, there's lots of answers right there, Jacob. That doesn't make them right. On a multiple choice test, 3 of those answers are always wrong.
No, but in the center.
It's 84, Mr. Ellis.
That's the original, Jacob. We want the new shape,
84.
which is a bigger parallelogram.
Yeah.
All right, since it's 1.5, we know the shape's got to get bigger, so we know it also can't be 37.3. I know what the answer is, Steven. 192 doesn't really make sense because we'd have to multiply it by, I don't know, like 3. So the only answer here that really makes sense is 84.
Actually, 4.
All right? So that was the perimeter side. Area side is where people messed up. Right?
I messed up.
Yeah. All right, triangle. Dilated with a scale factor of 0.5. The area of the original is 72. So here's our triangle with an area of 72. We have a new triangle with a scale factor of 1/2 or 0.5. So it's going to get bigger or smaller? Smaller. We want to know what that area is. Okay, so we still have our formula, but can we still use original times scale factor? No. Remember we talked about area that's in 2 dimensions, so it's got to be scale factor squared.
But didn't you have...
All right. So in this case, we have an original of 72 times what? What's our scale factor? 0.5 squared. Right? So we'd have to figure out what's 0.5 times 0.5. It's not 2.5. Stop guessing. Okay, 5 times 5 is indeed 25. But how many decimal places are there? There's 2 decimals. 1, 2. So 0.5 squared is not 2.5, it's 0.25. Whoops, 5. No, Jacob. That's not the answer. So we have 72 times 0.25. So the easier way would have been to do this with fractions, because then we would have had 1/4 of 72. I know it's easy, but you guys make 50s on stuff. That's because your English is bad.
Ain't is no word.
And plus we have people trying to say 5 times 5 is 10. That's not right. Whoops. My bad. So when we multiply this out, we do get 1,800 with how many decimals? 2. So it is 18. So a lot of people just put 36. You got to remember, we do area. You can't just multiply the original times scale factor and its area. It's got to be original times scale factor squared. Because there's no way, barring some really terrible math somewhere else, that you'll get the answer correct if you don't use this right here. Okay? So we're going to write this down for each one eventually. So this one here, area ABCD has an area of 56. So we know this area is 56 square units. Okay, we want to know what is the new area. So to find that, we have an original. We want the new, which means we need to figure out what. What are we missing?
Scale factor.
Scale factor. So if we look at our side lengths, can we see a relationship between 4 and 7? Is half. So what's our scale factor? Is a half. Or 0.5. I'm going to use a half because I like that better. So what a lot of people did, they made the same mistake on this one. They said, what's half of 56? And they put 28. And I'm going to tell you, every single time, that's wrong. Okay, that's the reason why people missed every single question on the back. It's because they did the same thing for each one, and it's wrong every single time. This is 1/2 what? Squared. So we need to take 1/2 times 1/2, which is not a whole. We're going to practice multiplying fractions so we get this.
125. No, it'd be 2/4.
No, Lauren. 1 times 1.
It's 1/4. Finally, we got someone smart in this class.
So 1/2, hey, 1/2 times 1/2 is 1/4. The sooner you recognize that, the better off everyone will be. Oh.
Or did you mess up?
Sure. They're working on it. Work with them. All right. So we have 56 times 1/4, or 1/4 of 56. So we can multiply this straight across. We could say 56 times 1. And then 1 times 4. Good job. And then we just need to know what's 56 divided by 4.
14.
Is 14. Oh. Okay. Another way you could do this, if you don't actually want to go through this work, if you were able to recognize that the scale factor was 1/2, if you took 1/2 of 56, you'd get 28. But since it's 1/2 squared, we'd have to take half of it again. So half of 56 is 28. Half of 28 is
14.
which is our answer. So that's another way you could do it.
I got that one right.
Wonderful.
L7.
Well, when you have 4 answer choices, you can guess it right 1 out of every 4 times. All right.
Yeah.
All right. Catlin, draw 2 circles. That says Catlin. Wasn't that the girl from the Hunger Games movie? Katniss, Catlin, I don't care. All right. The radius of circle N is twice as much. So to go from here to there, what would be our scale factor? Doubled. So our scale factor would be 2. So we want to know, we're talking about area. So the new is still equal to the original times scale factor squared. Except what's our scale factor?
Squared. Half squared. Squared half.
If it's twice as long, that means our scale factor is, I meant to write that down, I think Leighton already told me this, is 2, which means scale factor squared would be 4, which means our new shape is going to be equal to the original shape times 4. So which of these statements make sense? M will have an area that's half as much as N?
No.
No. Will n have an area that's twice as much as m?
Yes.
If it's times 4, how much bigger should this be?
4 times.
Should be 4 times as big.
That don't look 4 times as big.
Shut up, Jacob. What you gonna do about
So circle m will have an area that's 1/4 of n.
One.
Well, if this is 4 times as big as that, then this is what fraction of that? Would be 1/4. So what's our correct answer? C. Okay.
That's where I got it wrong because I didn't get it. Like, when it was,
No! Yes, take it.
pick my phone last week.
All right. 2 triangles are similar. Oh, a lot of people missed this one.
Oh, D. Oh, I did it.
All right.
It's D.
It is D. The ratio of 2 perimeters is 2 to 5. Okay? So the simplest way to think of this, hey, remember, it's not worth anything if you just circle the answer. You actually have to show the work.
Yeah, we'll qualify Mr. Ellis.
So we could take 2 triangles, and since our ratio is 2 to 5, we could simply say the perimeter of this is 2, the perimeter of this is 5, right? So then we simply look, what is the scale factor between them? So if we have a formula, and since it's perimeter, we can use this one here, right? We have the new shape being how big? 5. The original being 2. So we think 2 times what number equals 5? Or if you can't think of that, how could you get it?
2.5.
But how could we get that? If we don't know what number times 2 gives us 5, we can work backwards and say what is 5 divided by 2? Which would be 2.5. So we can say our scale factor here is equal to 2.5. Okay? But we don't actually care about the perimeter. We care about the areas. So instead of looking at just scale factor, we need to know what? What have we said every time we've done area? It's always scale factor squared. So what are we going to have to do with 2.5? Square it. Because area is in 2 dimensions, Jacob.
Sorry.
Yeah, that was like day 1 stuff.
They went on.
So we do 2.5 times 2.5, we get an answer of
5. You can also think of it as quarters. 25 cents and 25 cents is 5. What?
Not really.
He's smarter than you and he's in a grade lower than you. You're not helping me.
Do you get 625 with how many decimals? 2. So our scale factor squared is 6.25. So the ratio between our 2 areas should be 6.25. So I should be able to take our original area and multiply it by 6.25 and get the new area. Is that true for answer A? We could just think, let's just use 6, just to save us some trouble. 2 times 6, does that equal 5? No. How about 4 times 6? Does that equal 10? No, not even close. How about 20 times 6? 20 times 6 is 100? No. How about 8 times 6? Well, that's 48. So what if we tried the actual thing? 6.25 times 8. So we get 0, 4. So 0, 2, somewhere. And we get an exact 50. So which of those could be the two areas? It's got to be D. No, you didn't. You might have guessed it right, but you probably didn't get it right.
No, he got it right.
Did you show your work? Did you just draw one square?
No.
Don't lie.
I didn't look. It says SF,
I missed that one.
All right. This is just like the warm-up we did. So I would draw two squares.
Oh yeah, this is the one we did.
So here's a square. Here's a new square. The new area is 256. It has a scale factor of 2. What is the length of the side of the original square? Okay? So, two things we could do. You could find the length of each side here. You could think what times itself equals 256, which you should know after the warm-up today, but let's assume you don't. The other way you could do this is we could actually work backwards and find the original area.
By dividing?
So if we have, this is scale factor squared since we're talking about area. We have a new area is 256 equals the OG times 2 squared. So what does 2 squared equal? 4. Very good. You know what 2 squared is. So 4 times some number equals 256. Okay. So, if we don't know what that is, how could we figure it out? We could divide it. We say, what's 256 divided by 4?
64.
That's 64. Which means our original area has to be what? 64.
So that's not the answer.
That's not the answer. It's not even an answer choice. It wants to know what is the length of one side.
So you'd have to divide by 4.
So you can't divide it by 4. No matter how many times you say it, you can't divide area by 4 to get the side length. That's perimeter. You can't really divide it by any one number. Remember, area is base times height. What number times itself gives you 64?
8.
So what's the answer?
8. Good job, Mr. Ellis. I came up with that. Good job, Mr. Wait. Don't you have Mr. Simon?
All right, make sure you did all these answers on a separate piece of paper. If you just realized now that you didn't do them on a separate piece of paper, rewind the movie, watch it again, and do it on a separate sheet of paper. Yes, children, you know how this works.